Welcome to this tutorial on the systems thinking framework called 7 Samurai. This is one of a series of tutorials that you will have access to on tools and approaches, methods and frameworks that may support you in your practice when it comes to applying systems thinking. This particular framework is one that I think you will find particularly useful to get a macro perspective on systems. And not just one system, but the various different systems that you need to think about when you are trying to understand or intervene in a particular situation. The 7 Samurai framework was proposed by James Martin in 2004 in this conference paper, which you can have access to using the web links that you can see on the screen. Martin's idea was that there were 7 interrelated systems that you had to consider in any efforts to understand or intervene. And he made an analogy of the 7 samurai after the famous Japanese film, where there were 7 underemployed samurais that were guarding a village. His proposal was that there are 7 systems that you have to consider, and in a sense, some of these are underemployed in as much as we don't consider them properly in our efforts to understand and to create change. What I'll do in this tutorial is run through each of these 7 systems in a way that helps you to understand where perhaps we need to pay more attention in our efforts to understand and intervene. The first system that Martin talked about is what he called the context system. This is just quite simply the here and now system. It includes things like people, procedures, equipment, all sorts of artifacts, and other aspects of the environment, the designed environment, and the natural environment. Martin proposed that the context system is one that is in many ways not well understood, and certainly that's what I find. We don't tend to pay that much attention to the here and now before we go about our business in trying to create change. There are a few things that we should do when trying to understand the context system before we go on to trying to intervene, and one of those is to understand the system boundary. Now, as explained in the HUM-SYS course, the system boundary is something that we decide for our own purposes. In other words, it's a social construct. So we delineate a system boundary for whatever purpose it is that we have. So that's one thing that we need to do when trying to understand the context system. Perhaps the system boundary for us is, for instance, an air traffic controller and their working position. Or perhaps it's wider to include the whole ops room. Or perhaps it's even wider to include the whole organisation, or perhaps even wider to include the aviation system, or even beyond. Another good starting place when we're trying to understand the context system is within that system boundary, who are the stakeholders that we need to be aware of? Who are the stakeholders that perhaps we want to influence? We can use the acronym PACT, or P-A-C-T, so people, activities, contexts and tools to get a better understanding of who are the people that are really of interest to us in our efforts at understanding and intervening. What are their activities? What are the multiple contexts in which they work? And what are the tools that they use? Now, the contexts can be various. For instance, we all live in a societal context. We live in a social and cultural context. We work in an organisational context, and within that there's a procedural context. There's also a technological context, there's an informational context, there's a regulatory context, and we have our own personal context, of course. And we work in time, and therefore there's a temporal context, and various others. We also have purposes, and we have our own individual purposes, and we have purpose as a group, and we have purpose as an organisation. That's also critical to understand when it comes to a context system. Within the context system, we all experience various demands, and we work under various constraints with particular pressures, especially when the demands are somehow exceeded by our ability to meet them. perhaps due to a lack of resource, perhaps due to the tempo of work, perhaps due to the constraints, or in all likelihood, a combination of all of those things. In understanding the context system, we want to understand interactions, remembering from the course that interactions within the system are really the subject of our analysis, not individual parts, but interactions within the system as a whole. In particular, how elements of the system interact each other to produce the overall effects and outcomes that we see at a system level. Another consideration is that systems have history and they change over time, and we often don't pay a lot of attention to the history of a system and how that's brought us to the place that we are at today. In neglecting history, we tend to repeat mistakes of the past, and that's why we have to pay attention to the history and try to understand how it's got us to where we are today. And within that context system, we often have problem situations, and that's one of the things that we want to understand and why we want to intervene. We also have opportunities, so that's another way of looking at a problem situation. It could be an opportunity. Martin called this P1. So we've got system 1, which is the context system, and within that system exists P1, which is problem situation 1. Now, Richard Cook and his co-researchers talked about the first story and the second story. The first story being about human error and violation, for instance, or component failure. The second story being about system vulnerabilities. And so in understanding a problem, we want to try to get to the second story. What is it about the context situation that's creating and sustaining this particular problem situation of interest? We're interested in influences. What's influencing the problem, and what are the multiple causes? We know that there's no such thing as a root cause, and generally there are multiple causes and influences that are bringing problems into life and also sustaining them. We also have multiple perspectives that we should use to understand a problem, because a problem from one perspective may look very different to another perspective. It may be more or less severe from different perspectives, for instance. There may be different causes from different perspectives. We should also understand base rates. Often when we have a problem, we neglect to look at the base rate of the activity. Let's say that there's a runway incursion. Then what's the base rates for runway crossings, for instance? Rather than intervening quickly without understanding base rates, we want to take into account the whole activity in light of the base rate of the activity. Therefore, we can understand just how much of a problem is. Otherwise, we might intervene and create unintended consequences when it may, in some cases, be better not to intervene at all. The second system that Martin proposed was called the intervention system, and this is one that we are very familiar with. This is basically what we would call the solution. At least it's the solution as we would imagine. So at this level of system 2, we want to understand what the goals are. So goals are future oriented. It's something that we want to do in the future. It should be specific, measurable, achievable, realistic and time-based, whereas purpose is much more rooted in who we are, our raison d'être, our reason for being. Now, when trying to produce an intervention system, we want to think about what kind of approach we want to do with that, which brings us on to the human-centered design and evaluation. So here we start in this process with understanding the context system. We understand user needs. We try to design requirements to meet those needs. We prototype and evaluate. And I'll come on to that in a moment in a bit more detail. Now, the intervention system creates changes to system 1, which is the context system, obviously, because we want to help resolve this problem. And so we go back to understanding again the people, their activities, their contexts and tools. But intervention systems can have unintended consequences, and so we want to be aware of those and to try to preempt them as much as possible. Going back to human-centered design, there's an ISO standard that was updated in 2019, But the ISO standard is 9241 Part 210, and it's called the Ergonomics of Human-Machine Interaction is the series, and then this particular part is Human-Centered Design for Interactive Systems. It starts with planning the human-centered design process, and then moves on to understanding and specifying the context of use, which is what Martin would call the context system. It then goes on to specifying user requirements, which comes in two parts. The first part of that is understanding the user needs. So we already know now who are the stakeholders. We should understand who the stakeholders are. We've done that work already. And what are their requirements? Now they may be quite different, and so we may have to design to various different users and various different user needs. Once you know the user needs, then we want to propose design user requirements or design specifications or design requirements, whatever you prefer to call them. But these are the requirements that meet the user needs. In other words, what should the system do to meet the user needs? Once we've got those requirements, we move on to designing solutions to meet those user requirements, which we might call prototypes. Once we've got a working prototype, we evaluate those prototypes against the requirements, and ultimately want to know is, are the needs that we've identified being met? Now, we may find that the prototype being evaluated doesn't work, in which case we either have to go back to understanding the context of use, remember, people, activities, contexts and tools. Maybe we've not understood all of those. Maybe we need to go back to the user needs, maybe we need to go back to the design requirements, or maybe we need to just go back to prototyping. So this can go in several iterations until you've got a design that actually meets your user needs, and then once you have, then you've got something that you can work with. We now move on to System 3. This is what Martin called the realization system. Now the realization system is also one that we're very familiar with, because this is the system that brings about the intervention system. So we have System 2, which is the solution that we have in mind. We have System 3, which is how are we going to bring that solution into effect. Here we have everything that's needed for implementation, so all of the people aspects, the organisational aspects, the equipment, facilities, materials, services, processes, methods, policies, all of those different things. Everything that you would normally need to bring about some kind of solution. And of course we've got human-centered design and evaluation process that I've just outlined. We've got risk assessment processes. Various different competences may be required that we'll need to think about. How do we get these competences in order to realise this intervention system? And we may have to consider the constraints and capabilities of commercial off-the-shelf systems, which is increasingly the kind of system that we are adopting. We are less able nowadays to design from scratch very often. Now what happens is that the intervention system becomes the deployed system. The deployed system is the solution that actually makes it into reality. It's the system that goes from the system as imagined to the system as found in the real world. The deployed system may not be the same, though, as the intervention system for various reasons. But this is the system that now we have to pay attention to, especially in service. So the realization system for System 2 produces an intervention system, and the intervention system in effect becomes deployed, and that's the deployed system where we are now at System number 4. What becomes relevant now is monitoring in service. It may be that you've had compromises along the way of your design and development process which break design assumptions. It could also be that there is use beyond design intent. And also the context system may actually have changed, almost certainly will have changed, because now you've introduced a new system into the context system. It will change all kinds of things. It may change, for instance, the competencies needed by the people. It may change the people needed. It may change their activities. It may change that it may be a tool that they use, and therefore it's changed the tools. There may be deployment pressure, which will also affect the context. There may be performance degradation over time or since design. Users may compensate for the lack of certain functions or for difficulties in achieving certain activities that they want to do. They will also adapt. They may not perform in exactly the same way that was imagined during the design process. There could also be unforeseen interactions between systems. Now that you've introduced your deployed system, which could be an electronic system, it could be a procedure, it could be a checklist, there could be now unforeseen interactions between your system and other systems that already exist. Now this deployed system now creates an entirely new context system, similar in many ways to this context system that you had before, but now things have changed because you've introduced a new system to that context system. What can happen now is that we have unintended consequences. So you've introduced a deployed system which creates new problems that didn't exist before. It may or may not solve the old problem, but it may also create new ones. So we call those P2 or problem 2. And as I mentioned earlier, that creates a modified context system. The combination of deployed system and any unintended consequences or secondary problems creates a modified context system. Now there may be more than one unintended consequence, and these will all need to be addressed in some way. And the unintended consequences may be different to, or they may be worse than, the original problem in some cases. There'll be a need for operational resilience because the system has been deployed, and therefore somehow the people at work will need to be able to work with it or work around it. And again, there are changes to the context system that need to be monitored over time. This might involve all kinds of methods for in-service monitoring, such as observation, such as interviews, such as data analysis, or even questionnaires, for instance. You could use a variety of social science and other methods to get that kind of data. We now move on to the fifth system, which is the collaborating system. Very often when you introduce a deployed system, it doesn't work on its own. It has to collaborate with other internal systems. It may need to exchange data, or there may be collaboration which is more procedural or human. These collaborating systems may also need to be designed using a human-centered design process, or they may need to be adapted. Here again, systems thinking methods and systems integration methods can come in useful to understand these interactions between your deployed system and the collaborating system. You may need to think about interface standardization, because now you have a deployed system, and especially if it's any kind of interactive system, we'll need to think about the interfaces with other systems. Those may be hard electronic interfaces, or they may be, let's say, soft interfaces between people. It may be interfaces of the form of reporting systems, for instance, or communication systems. Now again, the context system is changing all the time, and there are interactions with your intervention, and so you need to consider those. We now move on to the sixth system, which is called the sustainment system. This one is difficult to delineate in many ways from the collaborating system, but it sustains the deployed system over time, and it may need to be developed or modified by the realization system, which is system 3. Martin talks about the sustainment system in terms of logistics. So the various logistical functions that we usually consider, such as water, waste disposal, power, energy, and so on, these are typical logistics issues that need to be considered in sustaining your deployed system. It could also be, for instance, training or refresher training. Perhaps your refresher training has been outsourced to an external organisation, and so that becomes a sustainment system as well. There may be unsupportable or unsustainable features and functions that you may need to consider. How do you sustain all of the various functions and features that you wish to retain in your deployment system? Now things get even more complicated because we have the seventh and final system proposed by Martin, which is the competing system, System 7. all the time that you've been developing your system, your intervention system, which became the deployed system, another system came along which competes and somehow addresses the same problem. Maybe it addresses it better, maybe it addresses it just more efficiently or more cost efficiently. Competing systems will need to be monitored throughout the whole design and development life cycle, and they may be competing design systems, so competing artifacts, competing products. It may also be competing behavioural systems where people and groups adapt to actually achieve the same outcome without actually using your deployed system. As we bring the whole 7 Samurai framework together, it looks like this. So it looks much more complicated than when we go through one at a time. But what you can see is that we have a context system which creates or has a problem. The problem is being addressed by the intervention system, and a realization system is what's producing that intervention system and needs to understand the context system. Then we have a deployed system, which is system 4, which is what the intervention system becomes, but it's not exactly the same thing. The deployed system may cause secondary problems. The deployed system collaborates with system 5, which is the collaborating system. And then we have sustainment systems, which sustain the deployed system, and may need to be developed or modified by realization systems. Then we have finally competing systems, which may address the original problem, but also compete with your solution. There could be other interactions. For instance, I've identified these red ones, so the secondary problem now needs to be addressed by a new intervention system. We sort of start all over again. The collaborating systems may also need to be designed by new realization systems. That's it for today with this tutorial. I hope that was helpful, and it's a thinking tool that you can use individually and in groups to help to explore the kinds of systems and the kinds of considerations that you need to think about when you're trying to understand the situation and intervene. I hope that was helpful and look forward to speaking to you again.